Thank you for attending RSI webinar today. My name is Rafał Gawenda and I will be running today's presentation together with my colleague Artur Kosakowski. The topic of this webinar is how to create and run code verification of user-defined sections. You can find information about our new series of robot webinars under these links. Let me remind you about the concept of RSA webinars. We will focus on one or several topics in order to discuss issues frequently submitted to the support team. We'll begin with the general introduction of selected features of the program and develop these subjects further based on the feedback we will receive from you after each of the presentations. Please mind that these webinars are not supposed to be training sessions. The topic of today's webinar is how to create and run code verification of user-defined sections in Robot. We will show you how to create solid and thin-walled sections, how to use section definition module, and how to use sections created in Section Builder in model space and in design modules. The topic of next webinar is Results Connect Robot API Dynamo. Section definition module allows user to create and calculate sectional properties of section shapes not existing in standard style databases nor on parametric compound special tabs of new section dialog box. Important note, these sections cannot be used as separate sections in Robot. There are several ways to access section definition module. While starting Robot by selecting marked icons, while in model space through layout system, and from the pull-down text menu. It is possible to calculate properties for two types of sections, solid and thin-walled. Before starting of section shape creation, it's required to select section type by clicking on appropriate button. How to distinguish whether the section which must be calculated is solid or thin-walled? Some general rules are shown on this slide. Slenderness of section must be checked. For example, using thin-walled sections calculated in a section definition module in Style Design module. Of course, after activating thin-walled checkbox on member definition window. One can see calculations made according to thin-walled design rules on Detailed Results tab. Important note, thin-walled design is implemented only according to Eurocode's free code in Robot. Let's start with solid sections. There are three possibilities to create a solid sections from import. Section or parts of new sections can be imported from standard style database. But prior to that, section database from which section is imported must be declared in job preferences. Section shape can also be imported from DXF file. Mind that correct DXF file units must be set in Robot before importing DXF file. For sections with numerous curves, for example some aluminum profiles, be aware not to discretize arcs too much for reasonable calculation times. Section shape can be also imported from Robot native section file. Sec file is a file format used by section definition module to save shape of drawn section on external file. Using these three types, it's possible to combine previously saved drawings sections in order to build a new solid profile. Of course, it's also possible to draw a section in a section definition module or add some parts to imported section shape using drawing tools like polygon, rectangle, or circle. To create openings or cutouts geometry, use the same tools. There are a few additional commands to help creating correct section shapes, like translation, rotation, mirror, each of them having move and copy modes. Modification option allows to modify position by moving of section's characteristic points. Standardization merges several shapes, including opening and cutout shapes, into one single object. Note, there is no standardization feature for thin-walled sections. Additionally, modifications can be also made in Properties dialog box displayed from the right-hand side mouse click menu. Besides changing point coordinates in the table part of this window, it is possible to set selected shape as an opening or solid and assign correct material to it. Calculations of sections properties can be run from pull-down menu results, then geometric properties and selecting results, or using results button on the right-hand side toolbar. Results by default are calculated without properties for which program has to run time-consuming operations such as torsional moment of inertia, shear area, etc. Principal system of coordinates is calculated, and within this system, all properties are calculated with assumptions that y-axis is a strong axis, so Iy moment of inertia is to be equal or greater than Iz moment of inertia. Properties calculated in this system of coordinates are saved in database and used on model space for firm calculations. But additional calculations can be performed on demand. See bottom part of General tab. Results are presented on this window and also in Calculation node. Here we can see screenshot with explanations of all system indicators which can be displayed in section definition module after calculations. So as you can see, there is a principal system indicated, arbitrary, global, and central system. Let's look at a small example of solid section in robot. I will import section shape from the DXF file. So first of all, I will find the file, or before opening, we have to select correct units. So my section file is made in centimeter units, so I will set it as it is. So here's my section. Of course, inside I need the opening. So after selecting the contour, right-hand click, selecting properties, I can activate opening, and then after pressing apply, my section is made. Of course, we can, for imported section, we can add or make any modifications we want. So let's add some parts here, then here, and maybe we can make some cutouts from this part. Oh, sorry, like that. So I will delete this one and make another rectangle. To make cutout, we need to assign opening property to this shape. Let's say the same for this shape. Apply. And then we need to make standardization, so I will select all pieces of my section and then run standardization. So as you may see, now one on the shape is created. I'm sorry. Results calculations on demand. We can open results window. So without ticking anything on this window, principal system of coordinates calculated on all these results presented. Central system, arbitrary system. So we can specify the rotation angle if you want to check properties in a given system. Or on General tab, we can activate additional calculations on demand. So after activating all checkboxes or some of them, after pressing calculate, we need to spend a little bit of time waiting for calculations. So all the missing values now are calculated and presented on this window. Also, the same results can be seen in calculation note. Let's go back to presentation. Saving of sections. Section shape can be saved in external file as a seg file. It's a section builder native file where we can save only shape of the section. Section shape and calculated properties can be saved in user section database to be later used on model and in design. User section database is named user by default in English. The default user section database file name is ruserpro.xml file. The path to this file is shown on the bottom of the slide. Saving to database can be performed from File menu or by button on the toolbar. As mentioned before, section properties saved in a user section database are properties calculated in a section principal coordinate system with y-axis assumed as a strong axis. A few rules how to save section. Section name is limited to 4 letters only, maximum to 4 letters. No digits in the name. dim1, dim2, or dim3 fields are not related to real dimensions. They help us to identify sections within the section family. Only dim1 field is mandatory. Section type choice is necessary when created section is needed to be designed. Each design code defines verification paths for given section types. Therefore, the selection of section type determines the code verification formulas used for code checking of this section in Steel Design Modular. Section shape selection should be made from the scroll-down menu with the question mark sign. Then it is required to fill data in these additional fields appearing at the bottom of this window. Robot does not make it itself. Not all section types are listed there, only the most common ones. Full range of available solid section types and numbers can be found in Robot Help or under this link. To use them, it will be required to edit section data in section database. We will talk about this later. Why it is so important to select correct section type? For the correct stress calculations, see left sketch. If section has a shape determined, correct characteristic points are considered in stress calculations. See blue points on the drawing. On the right-hand side, not correct points for stresses are considered. Let's go back to robot and see how to save the section. So our section is already calculated and we can save it to database for later use on model. So I'm selecting the option to save section to database from the toolbar. There is just only one editable user section database, so I will use the one we have. And then let's name the section. As you may see, there is no way to input more than four letters in the name field. So I will call this solid section. We can specify dimensions or field in dimensions, so I will type 100. And in case of designing this section later on in robot, we have to select section type. So let's consider we want to use this section for design as a tubular rectangular section. So I will leave these fields with the values as shown on the default, but of course for correct design these values must be properly filled. After pressing OK, if the section is calculated already, section is automatically immediately saved in the database. If created section is composed of several objects contour, it is possible to assign different material to each object or contour in Properties dialog box. Solid composite section definition is the same as solid section definition, except that it is not possible to perform standardization with the object composed of different materials. The fillings of sections with two or more materials may not be displayed with colors corresponding to defined materials, which depends on the way they were drawn or defined. One can change that from the pull-down text menu Edition, then Order, and selecting foreground or background on previously selected object. Solid composite sections are treated as homogeneous sections. Depending on base material choice, weighted characteristic values marked with the stars are calculated from geometrical values and from the material's Young modulus ratios. Let's look at our example. So let's consider that in the middle I will fill my section with the concrete, and then outer edges, let's say I will assign with material of steel. So now we have composite sections and we can look at the results. So as you can see, the weighted results are calculated, presented with the star on each tab, and changing the base material, we can see automatically value change in results. Let's look at Finwald section modular. There are two possibilities to create Finwald sections from import. From the .exef file, only the neutral axis of the section should be drawn by line or polyline in the .exef file to be imported. Thickness of the section will be defined after import. Shape can be also imported from the section file, sec file, the same as for solid sections. This was covered on slide 12. Section shape drawn by tools existing in this module. Note that only neutral axis should be drawn and thickness is applied to these lines or polylines. Drawn line polyline can be on external or outer fiber. There are a few additional commands to help creating correct section shape, like translation, rotation, mirror, the same as for solids. See slide 14. Additionally, modification can also be made in Properties dialog box, displayed from the right-hand side mouse click menu. Besides changing characteristic points coordinates in the table part of this window, it is also possible to change thickness there. Calculations can be performed the same way as for solid sections. See slide 16. Results are calculated with the same assumptions and also presented in similar way. Additionally, in table form on the last tab. All the results are also available in calculation note. For Finnwald sections, additionally to principal, central, and arbitrary system, center of gravity and shear center are graphically displayed. Let's look at example. So first of all, when we want to design new Finnwald section, we have to select new Finnwald sections from the toolbar or from the file menu. So I will say select new Finnwald sections from the toolbar, then I will import the EXEF file, but as usual we have to select or choose correct section dimensions. In my case I will use millimeters, and then open the EXEF file. Okay, and as you can see, my section shape is imported. After selecting it, you may see the selection is made on the neutral axis, and then when we, for example, change the thickness of the section, it's done automatically like that. So I will go back to the thickness of 2. Okay. Let's see the results. This time I will run them from the pull-down menu. So now we can see all the results presented for Finnwald sections, principal, system, arbitrary, and then all results in each characteristic point of the section. Graphical results, additional, as you may see, additional results in graphic form. And in the calculation note. Like for the solid section, shape of this Finnwald section can be saved on external file, seg file. Section can be saved in user section database to be later used on model in the same way as previously discussed during solid section presentation. Saving to database can be done from file menu or from the toolbar. Naming rules are the same as for solids. For Finwald section, it's not possible to select Finwald sections types in the Save to Database dialog box. Therefore, it's recommended to leave sections type as undefined with question mark sign. In fact, if created Finwald section needs to be designed according to Eurocode, the correct procedures should be applied. They are available under these links. Correct Finwald section types can be found there also. We will show correct step-by-step example path starting from Finwald section import to still design now. Every section database can be also viewed, and we will use this section database viewer to adjust section properties. Section database viewer can be run from Tools menu, selecting section database. Paths to the database are shown on the bottom of this slide. But only user section database can be edited. Before editing, it means making any modifications, please display all database columns on viewer and adjust units display if needed. When changing a value in a table, change line to validate modification or press Tab key on keyboard to leave the cell. Let's go back to our model. Let's assume that we want to design this section on our model, use it on our model, so we need to save it to the database. So I'm selecting this from this toolbar, then name it in the same way as we did before. So I will call it Fin. Let's say I will type 200 here, and we cannot select section type here. We have to do it later on by editing section database. So after pressing OK, section will be saved in the database. Let's look at the user section database or any sections which is installed together with the robot. So from Tools menu, we can use section database viewer and see and load the sections either from file menu or from the toolbar. I will load from the previously opened section the user database. As mentioned before, user database section file name is called ruserpro.xml. And as you may see here, I can have my solid section and the Finwald section. To make any modification to the database, it's recommended to display all columns here and set correct units we want to see. Units displays is available from the view menu, then units display here. When we scroll to the far right end, we can see the checkboxes here. So as you can see, the C section, it's a Finwald section. This one is the solid section. To design properly Finwald section, we need to adjust section type. As for now, you can see the section type is equal to 0. If you look at the links on one of our slides, how to create properly and save properly Finwald section to the database, you can see what types of the section should be filled, and at the bottom of this page you can see the link to the PDF with Finwald section type. I have already opened it, and you can see all available Finwald section types in this document. So our C section is a kind of view profile of type 1005. It's not only the section type number required to be filled, but also some additional data. So after zooming a little, we can see all required additional data which should be filled in the database. So let's go back to the viewer database viewer, and now I will type here 1005 because it's section type number, and then we need additionally to input parameters like RA, radius, thickness AA, and the C part P1L. So let's find these fields in the database. EA, let's consider it was 2 millimeters. Then RA, radius 6 millimeters. And then we should find P1L with 20 millimeters. And now you can see the correct section shape is visible in the viewer. Now this section is properly defined for section for steel design module for design purposes. So I will close the database viewer. And go back to model space. So on the model space, I need to create, for example, 2 bars. For now, it's not important, the section, because I will load the section from our user database. So first of all, I need to select user database and then consider solid section, and this one, thin wall section. Then I will apply to the top beam solid section, bottom thin wall section. Okay, let's add some supports. Okay, so the section shapes, you can see them. And here's the C shape. For design purposes, of course, we have to add proper member types. So let's consider the solid sections as a beam section, and bottom one we have to calculate as a thin wall. So on the member types, we have to additionally activate thin wall section check. It means we have to mark this thin wall section checkbox. Okay, save, close, and this one can be assigned to the bar number 2. Let's calculate it. And let's go to design module. Okay. So as you can see now, sections are calculated. Let's go back to presentation. Some hints at the end of our presentation. It is possible to create user editable database. In fact, from the section database viewer, one has to select the new database button, then specify correct database file name, database name, description, and set correct units. And what's most important, leave standard database checkbox unmarked. Otherwise, the section database will be not editable. Then database will be created, and to use it in a model, it will be just only needed to open it, declare it in job preferences. If created section is not symmetrical, then principal system in which section characteristics are calculated is inclined according to alpha angle. This angle can be seen when section is included on the model. Default section orientation on model is the same as shape drawn in section builder module. For easier section modification, use coordinates of points in the properties dialog box. Display of points numbers defining an object can be turned on in View menu. Some hints for composite sections. As weighted characteristic values are calculated from Young modulus ratio, it's not possible to take, for example, two steel materials, as Young modulus ratio will be equal to 1. Inertia of torsion will not be calculated for solid composite sections. Once saved in user database and included in model, it will not be possible to change material of a solid composite section. It is not possible to create multi-material fin-wall sections. There is a possibility to use database of complex sections for import purposes, to use it as it is, or for editing or modifying. Seizing the opportunity, I would like to introduce to you Autodesk Knowledge Network site, where you can find useful articles on the topics covered during this webinar, as well as on many others. Thank you for attending today's presentation. Now we can open question and answer sessions regarding the topic for which we run presentation today. Feel free to ask questions in questions panel of GoToWebinar meeting.
Thank you, Rafał, for great presentation. So, as Rafał said, you are now welcome to ask the questions. But maybe before that, I will do a bit of advertising. I hope that I will not be killed for that. But actually, one of robot users, which also helps us a lot on the robot forums, Stefano Paschini, has just published his application for calculations of concrete field columns, which perfectly matches the topic of today's presentation, and also links to the topic of the next presentation. So I strongly encourage you to have a look if somebody is interested. I will try to post the link so that anybody can actually access it. Okay, I hope that's went to all attendees. So, okay.
Not to only one.
So right, so please free to ask questions. And by the way, Stefano, thanks a lot for your great help on the forum and with the applications.
There is a question how to correct or add sections to the databases. XML editor only. In fact, XML file is a kind of the text file, so it can be edited either by any XML viewer or by our tool for section database. But it's not ordinary text file, so it's better either to use this our tool or correct XML database viewer. But we strongly recommend our section database viewer to control it in kind of graphical, visible form. So it's the question, if you are unaware of your section, whether it's Finwald or solid, and leave it with section type unanswered, robot will select option for you. No, the program does not select. As you may see, when you save the section which was designed or calculated by section definition module as a solid, then the checkbox which is in Finwald column displayed is not marked. So it means if it's not marked, it's solid section. Of course, on demand, while editing the database, we can mark it. So if the section is saved as a solid, this checkbox is unmarked. If it's marked as a Finwald, it's marked. But it does not force program to properly recognize part for steel design. Steel design is based on the section shape type numbers. So you have to additionally fill properly section shapes here, and then additional data if required. So for some sections, solid sections, you can fill this data on the saving to database window. For Finwald, basing on this document, you have to additionally fill some fields in section database.
So there was also a question whether it is possible to edit native or standard databases. The bottom line, it is not what we recommend. However, it is possible when you just uncheck the standard database marked, which is available in the properties of the database. But personally, I'd rather suggest that you copy this database, give a new name or give it a new description, and then edit. Just in case you make any mistake, you may return to the original file. Yeah, the standard database checkbox at the bottom of the properties. You need to mark it, unmark it first. And of course, the read-only attribute should also be removed from the file.
There is maybe one hint, because it's also possible to copy sections between databases. The easiest way is to mark record in the table, and then Control-C and Control-V in the new database or different database. But there is one limitation or condition. Not all the databases are made in the same order. I mean, not the columns inside the database are stored in the same order. So for some databases, the columns order is mixed, and copying sections between databases may not be easy or possible. So in case of creating, for example, a new section database by copying, we will obey this limit, because the order of copied section database, order of columns in copied section database will be the same as the original one. There's a question about the section check, to show it once again. So I will go back to robot. So the section design is made in the same way as we do on everyday life, but for the Finwald section, it's important to select only, activate only Finwald check the bottom of this window, on the bottom of the member definition window. So after activating FinVault section check additional conditions, the correct section shape type must be set in the database, and the checkbox, I guess, at the end of the record must be marked. And then the rest of the design is made in the same way as for Sali's standard section database.
So any other questions that we could try to answer? Okay, what is the base to the couple sections? So there is the option to import the predefined sets. Maybe Rafa will be able to show.
So let's start with the solid section. And this is the predefined set or database, we called it. And you can, for example, import section, this kind of the section. Of course, if it's not fitting to your demands in 100%, after importing you can modify it as you like. For example, make the opening or whatever. Oops, sorry. Stay still. So this is the way. Or you can draw the section or import the XF file with the contours made by lines or polylines, circles, and then assign properly materials or openings as a property. So So Stefan is asking about two FinVault C sections back to back. Let's try to do it. Okay, section shape. So I will use my section I used previously. Import FinVault. Okay, then we have to make mirror, let's say. Oops, sorry, copy. Okay. So we have properties calculated this way. If they are separated, Stefano, of course they will not be calculated.
Yeah, there was a question about box sections with additional flanges and how this is recognized in the steel design module. So basically the rule is that after you created the shape of the section and you calculated its properties, you assign section type as was shown during the presentation. And this selection determines two things. First, which code formula, verification formula are going to be used, which verification path is taken, and then based on the slenderness of walls calculated according to the parameters you entered, which class the section is going to be assigned to. That's for the general rules, but all the properties are used as calculated for the exact shape you entered. So we still have a couple of minutes, so perhaps anybody would like to learn something new, anything that we could help with.
If there is no more questions, I would like to thank you for attending this webinar and invite you to join us for the next one, which will be on 18th of November, covering the topics about Robot API and Dynamo. And I would like also to mention that, as usual, the recording of this webinar will be available soon on our YouTube channel, and the presentation will be uploaded within a short time on the box and published on our forum. Thank you for attending this webinar. Have a nice day.